In the previous lesson, we've learned how to look at something that is growing exponentially and figuring out how much of that we're going to have after a certain period of time. And we use the equation that we have here to figure out how much of that we're going to have depending on my initial amount, which was A, the rate at which it was growing, which was usually given as a percentage, and the time that we were looking at to see how much of it was going to grow. Now, today we're going to continue working with things that are changing exponentially, but instead of looking at things that are growing exponentially, we're going to be looking at things that are decaying, which means going down exponentially. And the equation that we've been using is the exact same one that we're going to use today, with the exception that now when you start with your whole, right, remember in the last lesson I told you we always include that one as part of our equation because we start with a whole. Now our whole is going to become smaller, it's going to decrease, it's going to decay, which means that the rate at which it's decaying or going down is going to be subtracted from our whole. So the difference between the equation that we used in the previous lesson for exponential growth and the equation that we're using now for exponential decay is that instead of adding our rate, which we did in the last lesson, we're going to be subtracting the rate when we are talking about something that is decaying exponentially or going down exponentially. But everything else remains the same. A is still our initial amount, whatever you're starting with. R is still our rate divided by 100. And X is the time. In the previous lesson, I used T, and we could use T here as well, or you can use X, whichever one you prefer, as long as it's just a variable there to represent time or the time that it has passed. So let's look at the example that we have here. It says in 2018, you bought a new car in 2018, you bought a new computer for $2,100. The computer decreases, that should say the computer value. The computer value decreases by 50% annually. So every year, the value of the computer is going to go down by 50%. So every year, it'll be at a value that is half of what it was before. So the first question says write an exponential decay function to represent the value of the computer after t years. So I know that my final equation or my final function should look something like y equals a parentheses 1 minus, since I know that the computer is decreasing, so this is decay, 1 minus r to the t power or to the x, whichever variable you want to use. So now my initial amount is whatever my computer was initially worth, which was $2,100. My rate at which is going down is 50%. And remember, you always have to divide your rate by 100 to convert it into a decimal. Whether this rate is given to you, whether the rate is a percent that's a decimal, or whether it's a percent that's a whole number, it doesn't matter what type of number the percent is. You always have to divide it by 100. So I'm going to go ahead and do 50 divided by 100 to give me 0.5. So that's my rate, that's my R. And here it says write an exponential decay function to represent the value of the computer after t years. So right here in part A, I still don't know what the time that it has passed is. So I'm just going to write t for time. So now I get to take all this information and I get to substitute it back into the equation over here. So I have y equals, my initial amount A is 2,100, parentheses 1 minus 0.5, which is my R, my rate, to the t, because I don't know how much time has passed yet. And now I'm going to go ahead and simplify that. Notice that this whole, this 1 over here, since we are since this is decreasing, since the value of this car is going down, what we're going to have inside of that parentheses when I simplify this is going to be a lot smaller than 1 because it's decreasing. So I have 2100 parentheses 0.5 to the t power. Okay, so this 1 has now turned into a 0.5, which is something smaller, given that it's decaying and it's decreasing. If we were looking at growth, then whatever's inside of here should be bigger than 1 since we're adding to it. And this is something that's going to help you in the upcoming lesson after this one. Okay, so that's my equation. Now I'm going to go ahead and use my equation to answer what I have in part B. It says, what will be the value of the computer in 2021? So I'm looking for the value of the computer in year 2021. Now, that doesn't mean that I'm looking for the value of the computer in 2021 years. I'm looking if the computer was bought in 2018. If my computer was bought in 2018, and I take it and I have that computer all the way up until 2021, what would be the value of that computer after all that time has passed? So first I have to figure out, okay, if I'm going to use my equation y equals 2100 0.5 to the t, well, I need to know how much time has passed. I need to know what is the time here. Now, sometimes in some problems, like we saw in the previous lesson, they might tell you it was 10 years or 5 years or 3 years or 1 year or 12 months, 32 months, whatever the time that is being measured, whatever the time is being measured in. However, here they're not giving me the time. They're giving me from 1 year to the other. So now first I have to figure out how much time has passed from 2018 to 2021. And if I subtract the two, you'll see that from 2018 to 2021, that'll be 3 years. So this is what I want to take and input into my equation over here. So I have y equals 2100 parentheses 0.5 to the third power, because that's how much time has passed. And when I put this into my calculator, I get y equals 262.5. So after 3 years, from 2018 to 2021, my computer will be worth $262.5. So the main point today is to remember that today we're looking at things that are decaying, they're decreasing, so we're no longer adding the rate, we're taking away from the whole, and we're subtracting our rate from that one instead.